Welcome everyone. Today we aren't just memorizing the formulas, we are building a toolkit. I heartily welcome you to the Math Simplified by HM channel. Think back to Carl Gauss when his teacher tried to keep the class busy by asking for the sum of integers from 1 to 100. Gauss saw what no one else did, the beauty of pairs. He instantly found the total was 5050. Today, we apply that same genius to find the sums of natural, even, and odd numbers. Please like and share this video with your friends, subscribe and hit that bell icon for more updates. We are going to explore three different ways to derive these patterns to ensure you really get the match. Grab a notebook, pause as needed, and let us get started. The foundational tool, arithmetic progressions. Every sequence we explore is an arithmetic progression where the difference between consecutive terms is constant. Formula: using the nth term Tn and first term T1, Sn is equal to n upon 2 into bracket T1 plus Tn bracket complete. Second formula using the first term A and the common difference D. Sn is equal to n upon 2 in bracket 2a plus in bracket n minus 1 bracket complete D bracket complete. These are our two master keys. The first, n natural numbers, the simplest sequence in mathematics, 1, 2, 3, 4 and so on up to n. First term a is equal to 1, common difference d is equal to 1 and nth term Tn is equal to n. We will prove this sum using distinct mathematical paths. Gauss reversal method. Write the sequence forward. Sn is equal to 1 plus 2 plus 3 plus n minus 1 plus n. Write the sequence backward. Sn is equal to n plus in bracket n minus 1 plus in bracket n minus 2 plus 2 plus 1. Now add them together vertically. So we get 2Sn is equal to n plus 1 plus n plus 1 plus n plus 1 plus n plus 1. Note this occurs n times. So simplifying, we get 2Sn is equal to n into bracket n plus 1. Dividing both sides by 2, we get Sn is equal to n into bracket n plus 1 whole upon 2. Name this as equation 1. Now the arithmetic progression sum formula. Apply a is equal to 1, d is equal to 1, tn is equal to n. So Sn is equal to n upon 2 first term plus last term. Subtract the limits. We get Sn is equal to n upon 2 in bracket 1 plus n. Rearranging for convention, we get Sn is equal to n upon 2 in bracket n plus 1 bracket complete. So again Sn is equal to n into bracket n plus 1 whole upon 2. Now arithmetic progression sum formula where a and d is known. Sn is equal to in bracket n upon 2 square bracket 2a plus in bracket n minus 1 bracket complete into d square bracket complete. Here we have a is equal to 1, d is equal to 1 and n is equal to n. So substituting these values, we get Sn is equal to in bracket n upon 2 into square bracket 2 into 1 plus in bracket n minus 1 into 1 square bracket complete. Simplifying, we get Sn is equal to in bracket n upon 2 bracket complete into square bracket 2 plus n minus 1. Simplifying this, again we get in bracket n upon 2 bracket complete into bracket n plus 1 bracket complete. So simplifying this, we get Sn is equal to n into n plus 1 whole upon 2. The foundation is set. We can now use this formula to unlock the next sequences. The first n even numbers 2, 4, 6, 8 dash dash so on. First term T1 is 2, common difference D is 2, last term Tn is equal to 2n. Three paths to one truth. Method 1, first term plus last term using the limits of the sequence. Method 2, factoring, leveraging our foundational natural numbers theorem. Method 3, AP expansion, brute force algebra using the common difference. Method 1, first plus last term, Sn is equal to n upon 2 in bracket T1 plus Tn. Substitute T1 is equal to 2 and Tn is equal to 2n. We get Sn is equal to n upon 2 in bracket 2 plus 2n. Factor out the 2 inside the brackets. We get Sn is equal to n upon 2 into 2 bracket 1 plus n. The 2's from numerator and denominator get cancelled out and we get Sn is equal to n into bracket 1 plus n. Factoring the foundation. Write the sequence Sn is equal to 2 plus 4 plus 6 plus dash 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 plus 2n. Factor out the common 2, we get Sn is equal to 2 into bracket 1 plus 2 plus 3 plus dash dash plus n. Bracket complete. Substitute the natural numbers formula we already proved and named as equation 1. We get Sn is equal to 2 into square bracket n in bracket n plus 1 bracket complete square bracket complete upon 2. Name this as equation 2. Now numerators 2 and denominators 2 gets cancelled out and we get Sn is equal to n into bracket 1 plus n. Method 3rd, arithmetic progression sum formula expansion. Sn is equal to n upon 2 into square bracket 2a plus in bracket n minus 1 bracket complete into d square bracket complete. Substitute a is equal to 2 and d is equal to 2 and n is equal to n. So we get Sn is equal to n upon 2 in square bracket 2 into 2 4 plus in bracket n minus 1 bracket complete into 2 square bracket complete. Expand the inner brackets. We get Sn is equal to n upon 2 in square bracket 2 into 2 4 plus 2 into n 2n and minus 1 into 2 minus 2. Simplifying inside the brackets, we get Sn is equal to n upon 2 square bracket 2 plus 2n. Factor out 2 and cancel with numerator and denominator. We get Sn is equal to n upon 2 into 2 in bracket 1 plus n. So numerator and denominators 2 get cancelled out. We get Sn is equal to n into bracket n plus 1. The first n odd numbers. A sequence defined by gaps 1, 3, 5, 7, dash dash 2n minus 1. First term a is equal to 1, common difference d is equal to 2, nth term tn is equal to 2n minus 1. Three paths to one truth or addition. Method 1, first plus last term applying the limits. Method 2, AP expansion applying the common difference. Method 3rd, the subtraction method, subtracting even sums from natural sums. First and last term method, Sn is equal to n upon 2 in bracket T1 plus Tn. Substitute T1 is equal to 1 and Tn is equal to 2n minus 1. So we get Sn is equal to n upon 2 in bracket 1 plus in bracket 2n minus 1 bracket complete square bracket complete. Cancel the ones. 1 minus 1 gives 0. So therefore Sn is equal to n by 2 into bracket 2n. Again numerators 2 and denominators 2 get cancels to each other. So we get Sn is equal to n into n giving n square. Method 2, arithmetic progression sum expansion. Sn is equal to n upon 2 in square bracket 2a plus in bracket n minus 1 bracket complete into d square bracket complete. Substitute a is equal to 1 and d is equal to 2 and n is equal to n. So we get Sn is equal to n upon 2 in bracket 2 into 1 plus in bracket n minus 1 bracket complete into 2 bracket complete. Sn is equal to n upon 2 in bracket 2 plus 2n minus 2 plus 2 minus 2 sum gives 0, so get cancel out and we get Sn is equal to n upon 2 in bracket 2n. Again numerators 2 and denominators 2 get cancelled to each other and we get Sn is equal to n into n giving n square. Method third, the subtraction method. The OR sequence is just the sequence of 2n natural numbers minus the n even numbers. So we have 1 plus 3 plus 2n minus 1 is equal to 1 plus 2 plus 3 plus 2n minus in bracket 2 plus 4 plus 6 dash dash plus 2n bracket complete. Substitute our previous proven formulas. From equation 1 we have 2n into bracket 2n plus 1 upon 2, as here n is 2n. So n into n plus 1 becomes 2n into bracket 2n plus 1 upon 2 minus sum of even numbers. Recall the equation 2. We have 2n into bracket n plus 1 upon 2. Now distribute and simplify the numerators. We get 2n square plus n minus n square plus n. Then the plus n and minus n cancel and 2n square minus n square gives n square. So Sn is equal to n square. To wrap our session, let us review the beautiful conclusions we have proved today. We successfully established that the sum of the first n natural numbers is n into n plus 1 whole upon 2 by applying multiple methods like using the first and last terms, the general arithmetic progression sum formula, or factoring common multiples. We proved the sum of the first n even numbers is n into bracket n plus 1. We also saw how the sum of the first n odd numbers elegantly reduces to exactly n square. Having different methods to reach the same truth gives us a much richer understanding of these patterns. As we close, remember the quote, "Your potential is greater than the sum of all natural numbers." So unlock that potential through the power of consistent practice. Please like and share this video with all your well-wishers, colleagues and friends. Subscribe to the channel and click the bell icon to stay updated. Thanks all for joining. Enjoy the great time and keep exploring the mathematical patterns around you.